Today's lecture is going to we are going to study something called site investigation. We have studied before something called soil classification. In soil classification, we learned how to classify the soil, to know the types of the soil, to know the relation between the different types of soil, the different parameters of soil, from one parameter how to reach another parameter, and so on. So we have seen many things about the soil itself, but this is all theoretical. Now we need to know if I need to have to do a site investigation. First, let's define what is a site investigation. We said that there are many parameters that are very important in soil, like C, which is the cohesion, phi, which is the friction angle. How to get these parameters? It is not enough to know that this type, somebody tells me that this type is of soil is called sand. It does not mean that I can get the parameters. I should know the parameters. This for things that I know, but there is another problem. Maybe I don't know from the beginning. Not I don't know the parameter, I don't know what is there. I need to go, when you go to the site, you are going to see the surface of the site. But what is below? I don't know what is below. So I need to know what is below and to know the parameters of every layer from what is below. So this is what we mean by site investigation. Site investigation is trying to change the things that I see on site or do not see because it is below ground into numbers. I need to have numbers telling me that I have, say, sand with a depth of 5 meters with a phi angle of 30 degrees. This is very good because now I know the depth of the layer and I know the properties of this layer, so I know everything. Followed by another layer with a depth of, say, 3 meters with clay with a C value of so and so. So now I changed what I see and what I do not see into numbers that I can use in my design later. So this is exactly what is site investigation. It's the process that precedes any project for the purpose of identifying the nature of the soil, the earth topography and its groundwater, and the suitability of this soil for construction. This is a quick definition. You need to know the nature of the soil, topography, what is high, what is low, groundwater, is there water or there is no water, and the suitability of this type of soil for construction. Site investigation is required to determine properties of soils and rock. The purpose of this site investigation is to establish parameters for foundation and superstructure design. This is mainly our target. My target is to build a structure. How to build a structure? Then I have to start with the foundation. Then any foundation? No, I have to design this foundation based on what? Based on some parameters that you are going to give me. Give me based on what? Based on a site investigation. So it's the first step in any project. This study is carried out to ensure the safety of the soil and to ensure that future problems do not occur. This site investigation, I do it for safety and to ensure that in future I don't have problems with these buildings. You have seen lots of buildings finished. You finished a very big, important building or a very prestigious building in a very prestigious compound, and once you go and live inside it, you find that walls starts to crack. Why? Because you did not do adequate site investigation to prevent this. So it is a very important thing. Just photos that you might have seen before. All of these photos say why you need to have a site investigation. Because if you do good site investigation, you can prevent this, you can prevent this, you can prevent this, you can prevent this, and you can prevent this, and lots of things similar to this. So if I have enough information, then I can do very good design, and my design stays safe all of the time. What we are going to study? We are going to study types of investigation, methods of site investigation, field tests, and geotechnical report. Types of investigation. In any investigation, I have many stages. Usually the first stage is the stage of data collection. If you want to study a subject in your university, you will just, before starting to study the subject, you have to ask people before you who studied this subject, was it easy or was it difficult? What can you tell me to pass this year easily? Then there is a period of data collection from people, collection from published data on the net, collection from books, from whatever. So usually before I go to a site, I collect data about this site. Then I can go to this site for preliminary investigation. It's not usually that we go and do the detailed design stage. Maybe I can just go at the beginning. You do this. You come to the university for the first day, you have an induction, you just check locations, check places, where is my lectures. It's just for info. You come to investigate what you are going to see the next of the remaining of this year. Then third stage is the detailed and the detailed investigation stage. I go with everything. I pass the whole year studying, going to lectures, labs, and so on. This is my original study that I should have taken from the beginning, but I started with an introduction. Then, once you have finished all of this, then now you have all the data available with you. Then you can start making your analysis. I collected data, but I collected data for a reason. I need to give the structural engineer what is the bearing capacity of the soil. So to get the bearing capacity of the soil, you need to take the data, put it in some equations, make some calculations, end up with what you need. So these are the steps for my investigation. The first step of my investigation is usually the data collection stage. In site investigation, we have really lots of data that are very important. If I do not take it with me from the first time, then I am losing many things that I may not get later, or I may get it with paying lots of money and time. First thing is hydrological data. I can just go look for some kind of books, published papers, places that maybe sell printed information about the area where my site is located, and I check these locations. They can tell me that from the hydrological means water, from the hydrological point of view, your site, maybe it is located on the way of floods that may happen. Sometimes flood happens every, say, 20 years. So maybe if you go now to the site, you will find it dry and very good and nothing there. But maybe after 1 year you find the flood coming and taking everything away at your place. So if you find a place showing the location of expected floods, then it is important. Or tell you where is, do you expect to have water covering the ground? Maybe in some places, what's called sabkha, where water comes on top of the ground. You can know this from before going to the site. Lots of information related to water. So hydrological data, I can collect it easily before going to the site. Aerial and satellite topography or photography. Google Map or Google Earth. Using these satellite images, you can see your site before going to the site and check if you have a problem on site. Maybe they are using now this site as a dump area. It's a problem. How can I go there? Then before going to the site, I know that I have a problem in this site. Topographical maps. Topography, the survey. You have taken survey, I think, as one subject. So people have done survey for all of Egypt, and they have published maps showing what is high, what is low, and so on. So if you just go to the authority that sells these maps and you just take or check the map of your area, you will know exactly what is the topography at your area. Geological data. You have studied geology. So there are also geological map that is published for each area in Egypt. So before going to the site, you see what is the geology of the area. When you know the geology of the area, you know what you expect to see on your site. So it's geology, topography, aerial photography, and hydrology. All of these are very important data that you can get while sitting on your computer at home or at office. The last thing is going to the site for checking, asking, seeing neighboring sites. Maybe if you check and go and ask somebody, if you go there and you find that there is a building that is being constructed now, so you can just go and ask them, did you had any problems? What did you see when you excavated the ground? Many questions that you can ask. Or it may be published if this site is a very important site, you can look for this published data on the net and you can get it. So all of these are very important data. They are not expensive. You can take it without major effort from your site. Next is the exploration for preliminary design. Suppose that I need to construct a city. Our architects or the developer will tell you that, okay, we are going to build the city at this area. We are going to divide the city into major parts. this part is the industrial part, this part is the housing for maybe buildings, here is villas, here is green areas and so on. Before you start constructing these items, just do a preliminary investigation. Instead of doing maybe 100 boreholes, you know what is a borehole? Instead of doing 100 boreholes, just perform 10 boreholes. These 10 boreholes, scatter them all over the site so that you can ensure that what you are going to see will be matching your expectation. So a preliminary site investigation is an investigation with a limited number of items that is done at an early stage so that I don't waste my time and money on something and then later I discover that it was not the best choice for me. Maybe the site is not suitable. Maybe within the same site I can shuffle. I can just take the high-rise building from this location and shift it to another location because the soil there is better, and maybe move a green area to put it in this weak spot. So I can change my architectural design based on this, or in many stages maybe prepare myself for the construction stage by doing a preliminary investigation to know what I'm going to face in the future during construction. So this is what we mean by the preliminary investigation. Then we have another type, which is the main type. It's the detailed investigation. The detailed investigation, I do it at the final stage of the investigation. I do the full investigation. I continue the preliminary investigation. This preliminary investigation, maybe I've only done 10 boreholes out of 100. Then in this case, I can do the remaining 90. So this plus the previous one, they form my detailed investigation. There is another type of investigation that is called the monitoring. Sometimes I need to say build an underground. So during construction, I have to monitor the buildings on top. Maybe I'm affecting this building, or somebody tells me that there is a problem in a building that was built before. Then I have to go and perform an investigation for an existing building to know what happened in the ground. Or maybe the initial investigation was not adequate. So I have to do an investigation either for during construction to follow up the construction stages to see the effect of this investigation on the buildings, or because already I have an existing building that is affected, and this building that is affected, I need to know why was it affected. It was not supposed this was not supposed to happen. So why this happened? I do an investigation and I study what is there. So this is what is meant by monitoring during construction, or in addition to monitoring during construction, you can add monitoring or investigation after problems that happened in any structure. In any investigation, I just said something called boreholes, and I will add something. In any investigation, I do boreholes. This is the normal. What is a borehole? A borehole is a hole, a tube that I drill the void of a tube that I drill in the ground, and during drilling I take samples out of the ground. So in this case I'm taking samples representing the full length of the borehole. It means that I can go down to a depth of whatever I need. By the way, this photo is for a machine, drilling machine, that was used here in Egypt in Dab'a nuclear power station during the investigation. The depth of the boreholes that were conducted there was 100 meters. So this machine managed to reach 100 meters below the ground and take samples 100 meters below the ground. So we can reach very big depths. But as you know, I need as much as possible to get the sample as it is in the ground. And it is not, suppose I have in the ground sand that is very loose. If I bring it, and during bringing it up, I just compress it, and then you give me the sample, I will look at the sample, I will tell you it is not loose, it is compacted. Because you've already compacted the sample to bring it from bottom to top. So taking a sample from the ground may affect the shape of the sample. It will not affect the material usually, because the material is sand. It will be sand. I will not take sand from the ground and on top it will be clay. It will be still sand. But the degree of the compactness of the sand will change. So the best thing for me is to do one of two things. Either to make tests in the ground itself at the required depth. If I manage to do the test on the sample on site at its location, then it is not moved. I don't have to move it. But if I have to move it, then it will be disturbed. So what can I do? I can use something instead of the boreholes called test pits or open cuts. Test pits mean in Arabic حفر مفتوحة, which means that I drill into the ground a hole. I go myself inside the hole, I see the sample with my eye, and I take the sample with my hand. So I can see it exactly as it is. But what is the problem of that? The problem is that I cannot drill 100 meters. I will just drill 2 or 3 meters. So I will be limited to a certain depth. I cannot exceed. So this is a problem for me. But I can mix. I can use boreholes. I can use test pits together. So this and this may help me a little bit, especially that usually the very weak soil is on top. The deeper you go, the better the samples. So if I can check the first 3 meters, okay, it may help in some cases in roads, but of course it will not. If I'm doing a building like the one that we are staying here in it, no, I cannot do just test pits. I need boreholes. This is good for comparison. You see this. This is the drilling machine that was used to drill 100 meters. This is mechanical machine. This is the first type of machines that was used in site investigation. Just a tripod and a pulley on top, and they just hang a tube on this pulley, and they use their effort and hand to push this tube into the ground, and the deeper it goes, and then they bring it outside, take the samples from it, and send it to the lab. So this is the shape of the first equipments for drilling. And by the way, they are still used in some places. places where you have maybe problems in transportation going to this place. Sometimes they use this type of drilling, but of course they are limited with the depth that they can reach. This is something intermediate. These are the normal equipments that we use to reach maybe 20 meters, 30 meters, 40 meters maximum. We can say that it is the normal practice for boreholes, but it is very good. The other one here, this was fixed with computers and everything was automated. You just drill, and while drilling everything is recorded. Once you finish, you take everything on a flash memory and put it on your computer. This is the end of the investigation. This is a little bit semi-automatic or semi-manual. Types of drilling. How can we drill? We have. So what are the types of drilling itself? Now we were speaking about the machine and everything, but now we are now speaking about how are we going to drill. It's either auger drilling, which is like a screw that penetrates the ground, or wash boring. Wash boring is something you have to imagine first. You remember in the war of 6th of October, they managed to penetrate the Bar-Lev wall using cannons of water. What is cannons of water? Just water jet, pushing the soil, so it takes the soil and bring it back while coming back. So water can drill, but jet can drill. So this is in the horizontal direction. Why not in the vertical direction? So what they do is that they connect. Maybe take this drawing. They take a pipe here with water, and then they connect it. Water goes inside the soil, and it takes the soil particles and bring it on top. What you need to know about this wash boring is that we use it to drill only, but not to take samples. Why? Because if you take samples that is washed, it means that water has already washed the samples, which means that it has already taken all the fine particles from the soil and take it away. What will remain with you is the big particles. So you are segregating the sample. Part of the sample is washed away, and the other part you have it with you. So it is not a very good sample. So samples taken by wash boring are not for use. You cannot test it. Then we have rotary boring. More or less rotary boring and auger, they are the same. The difference is that there is no screw, but there is a pipe that is being turned around in the ground, so it rotates and take the sample inside of it. But the idea is rotation to penetrate the ground. The fourth thing is called percussion drilling. It's not available a lot in Egypt, but it is available in many other countries. Percussion drilling is like hammering the ground. We are just taking our tube inside, just pushing it down, maybe with something, with a hammer, something like a hammer or a big weight. So once we push it, it penetrates the ground and takes samples and take it outside. So these are the types of the drilling machine that used for these types. There is another type of boreholes, but according to construction phase. It is actually related to what we have just said about the stages of the construction. If I am doing exploratory stage, then my investigation I will do exploratory boreholes at this stage. If I'm at the construction stage, then the borehole is called, it is a construction borehole. If it is at the end of the project and I'm just doing it to confirm what I have done, then it is a confirmatory borehole. It's not very important to know this, but just in case you hear something like this, then you know what do they mean with it. Let's see, construction boreholes. This type of boreholes influences the design and safety of the structure. So the Egyptian code for soil mechanics and for foundation design and implementation stipulates the rate and depths of these boreholes. At a construction stage, these are the most important boreholes. If you go to a site, how many boreholes are you going to do? And what depth you are going to reach? If I ask you, will tell me I will do 5 boreholes, 20 meters. If I ask her, she will tell me, no, I will do 6 boreholes, 25 meters, and so on. There should be something that guides us what is correct. So the Egyptian code has given us something that we can follow. This is the Egyptian code. The Egyptian code had given us this table. This is a translation of what we need from this table so far. It says that if you are exploring an area, it's not a construction stage, just for exploration, you can take one borehole every 200 by 200 meters to 400 by 400 meters. It means that one borehole can cover an area 200 by 200 or 400 by 400. This is for new area. I'm going to do to construct a new city, so this is the normal rate. But if I'm going to construct a building, then the code stipulates that you should have one borehole each 300 meters square. So 300. Why here he gave me meter square and in the other one meter by meter? Because in the other one you don't have structure, you have a land, so you have to divide this land. But in this case you do it below buildings or below the area that is located for a building. So in this area, you know that this area, say, is 1,000. I am going to build this 1,000 meter. How many boreholes do I need? 1,000 divided by 300, then it is 3 point something. So either I do 3 boreholes or I do 4 boreholes. The judgment is for me to see what is, if this is a very important structure, then let's take it 4 boreholes. If it is not a very important, then 3 boreholes. It depends also on the budget. If you have good budget, then you can increase. Low budget, you can decrease, and so on. But anyway, this is 300, every 300 meters square, you need one borehole. Suppose your building is only 300 meters squares. Are you going to take one borehole? No, the code says minimum 2 boreholes per building. So if I have a building that is 200 meters squares, I will take 2 boreholes. This is, I should have 2 boreholes because it's only one building, then I need at least 2 boreholes to depend on it. The other important thing is, in case of long distances, if I have a road, if I have a water pipe, something that it's not an area, it's a long distance, it's measured by distance, not by area. In this case, you do one borehole each 250 meter of this length. These are the important things in this table. So this table gives me the number. What about the depth? Another table gives me the depth. The depth is minimum 10 meters for buildings. If I have a building, then the minimum depth of borehole is 10 meters. But of course, it can increase to more than 10 meters, depending on what we are going to see in the next slides. Also, in case of not very important boreholes, like the boreholes for roads, the boreholes for pipelines, I can use it to be something like 6 meters, 5 to 6 meters as a minimum depth for the borehole. To determine the depth, then I have to know why I'm doing the borehole. I'm doing the borehole to study the area that will be affected by the new load. If I have a foundation, then this foundation is supposed to exert a big additional load on the ground. The ground already has some loads, maybe its own weight, maybe own weight of something next to it, anything that exerts load on this area. But my new building is going to exert new load. It will add. So to which depth this new load will affect the ground? If I put 100 Newton or kilonewton on the ground, will then this load continue on the ground until it reaches the other side of the earth? No, it will just affect few meters. How much? Scientists studied this and they told us it, of course, by experiment, they just experimented this and found that down to twice the width, the breadth of the foundation. If I have a foundation 2 by 6, then what is important is the 2, not the 6. So the shorter length or the shorter dimension, which is the breadth, I take double it below the ground. This is the area that will be affected by 90% of the load. The remaining 10% is not important, but 90% of the load will be within this area. So if I have a foundation this width, then I should cover twice this width below ground. If the width is big, then twice the width will be here. It will be bigger. So depending on the width of your foundation, you will define the depth of the boreholes. Because if my borehole should go to this depth or to this depth, if I have 2 types of foundations, then my borehole should cover the bigger. I should do a borehole that would give me all the data I need for the site. If in this site the maximum expected width of borehole is 4 meters, then I should cover at least 8 meters. And I know that the minimum for boreholes is 10 meters, then okay, 10 meter will be fine. But if you have bigger foundation, maybe 6 meters, so 6 meters by 2, it's 12, then I need more than the 10 meters, I will need 12 meters, 15 meters, and so on. So this is for shallow foundations. But what about deep foundations? Deep foundations means piles. You know piles? خوازيق. Piles is a type of deep foundation. Of course, it goes to the maybe it would reach 40 meters below ground, 50 meters below ground. Who knows? In this case, I need my borehole to cover the length of the deep foundation plus another 5 meters at least. So my borehole should reach this depth. Let's think of something here. At which stage do we do the boreholes or the site investigation as a whole? Before we start. Do you have a design for the foundations? No. You don't have a design for the foundation. You don't know the breadth, the width of the foundation. You don't know the length of the piles. You don't know anything. So what I've said is for your expectation. Your experience will tell you in a building that is expected, that is say 4 floors, I expect my foundations to be of a maximum width of say 3 meters. So 3 meters by 2, it's 6 meters. So if I take 10 meters, it will be fine with me. Also for piles, building 10 stories, I expect that my piles will be so and so, and I put. Suppose you are in doubt, you don't know. Maybe you can have more or you can have less. Then you can mix. Not all boreholes the same depth. Choose some boreholes deep and choose some boreholes not deep. So in case you need them, they are there. In case you don't need them, you did not waste all of the boreholes, but you've just wasted few of them. So this is what we need to see here. The second type is called the test pits. We said that boreholes distort our sample. It gives us samples that are in not the normal shape of it in the ground. So what can I do to see a better sample? I see for myself. The best thing to see for myself is drill a hole, go inside this hole, see the sample, bring it, check it. But as we said before, I can do this for a limited depth. This limited depth would be, in normal cases, 3 meters. This is, I cannot do more than that. Exceptionally, in some places, they can do more than that. Similar to the one in this photo. This photo was taken in Sana'a airport in Yemen. You see this yellow, not yellow, this blue helmet is the helmet of a person standing below. So this depth is at least 8 meters, and it was more than 8 meters. Because the type of ground can withstand drilling without problems, and the type of people working there are very experienced, so that they can do these small pits and they can go inside and come up without being harmed. So they have the experience to do that. We cannot do it here. Here is maximum 3 meters. So this is the test pit. Sometimes when I go to a site, I may find by nature something there that can help me, or not by nature, maybe it is man-made, but it was man-made in a later stage. Somebody came to this site, like this photo. Somebody came to this site, drilled all of this area. If you see these lines, the lines of a truck. So maybe they needed some material from this site, so they just came to this site and took some material and took it outside, or they wanted to build something and then they changed their mind. I don't know. But anyway, if you go to a site and you find that nature has drilled something, or you can see something use it, consider it that it is part of your requirement. In this site, we used this. We took samples from the sides here, and we put it as one of our investigated points. It's something that was there on site. So it's either open cuts made by you or made by somebody previous to this site or made by nature. It is there due to any reason, who knows? And this is the test pit. Sometimes test pits are called open pits. Both names are used and they are the same. Now we are going to study tests that we can do on site. Before that we were studying drilling. It's all drilling. But as we said, it is drilling to bring samples and take it to the lab. Can we do tests on site? It will be better. If I manage to do a test on site, then I don't need to take a sample and to send it to the lab. And in this case, I will get rid of all of the distortion that happens to the sample while retrieving it or while sending it to the lab. So we are going now to study some tests that are conducted on site below the ground. So it is very good because they don't have the accuracy or the degree of distortion in this is very small.